Preparing for a DevOps engineer at JFrog interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a reliable CI/CD pipeline for applications using JFrog Artifactory? I would design the pipeline around immutable artifacts. A commit triggers tests and a reproducible build, then publishes versioned packages or container images to an Artifactory local repository. The pipeline records build info, dependencies, Git metadata, and test results. JFrog Xray scans the artifact before promotion to staging. After integration tests and approval, the exact same artifact moves to production. I would use Jenkins, GitHub Actions, or another runner with short-lived credentials and automated rollback. While answering, cover source control triggers, build isolation, artifact immutability, repository layout, automated testing, promotion workflows, credentials, rollback strategy, pipeline observability, and deployment approvals. Question 2. What is the difference between local, remote, and virtual repositories in JFrog Artifactory? A local repository stores artifacts produced or governed by my organization. A remote repository proxies an external source, such as Maven Central or Docker Hub, and caches downloaded artifacts locally. A virtual repository presents multiple local and remote repositories through one logical endpoint. I typically give developers only the virtual URL, which simplifies configuration and improves availability. I still control which repositories it aggregates, because careless inclusion can create dependency confusion or unexpected versions. Make sure to cover storage ownership, proxy and caching behavior, aggregation, dependency resolution, naming conventions, retention, access control, and why virtual repositories simplify client configuration. Question 3. How would you secure a JFrog Artifactory instance used by multiple engineering teams? I would integrate Artifactory with the company identity provider and map groups to project specific permissions. Developers should receive read access only where needed, while C-service accounts get narrowly scoped publish and promote permissions. I would prefer short-lived access tokens over shared passwords, enforce TLS, restrict network exposure, and enable audit logging. Scheduled reviews should remove stale users and rotate credentials. For highly sensitive repositories, I would add network policies and separate administrative roles. In your answer, discuss identity federation, groups, least privilege permissions, project isolation, tokens, service accounts, TLS, audit logs, network controls, secret rotation, and periodic access reviews. Question 4. How does JFrog Xray improve software supply chain security, and where would you place it in a pipeline? Xray analyzes artifacts and their dependency graph against vulnerability and license data. I would scan during or immediately after the build, before promotion from a development repository. Policies can block critical vulnerabilities or prohibited licenses, while documented exceptions handle justified risk. I would also scan newly published intelligence against existing artifacts, because a previously safe image can become vulnerable later. Xray complements, rather than replaces, source scanning, image hardening, patching, and runtime protection. Be sure to mention vulnerability scanning, license policies, component graphs, watches, build integration, fail open versus fail closed decisions, exceptions, remediation, and runtime versus build time controls. Question 5. How would you implement artifact promotion from development to production without rebuilding? I would build once, publish an immutable version, and promote that same artifact across repositories or environments. The pipeline attaches build info containing source revision, dependencies, and environment details. Automated tests and Xray policies gate promotion, followed by an approval for production. Deployment references the immutable digest or version rather than latest. This approach preserves provenance and makes rollback straightforward. I select a previously approved artifact instead of rebuilding from a changed source tree. Focus on immutable versioning, repository promotion, build info, quality gates, Xray policies, approvals, provenance, rollback, and preventing mutable tags from undermining artifact identity. Question 6. A Docker image build is slow and repeatedly downloads the same dependencies. How would you investigate and improve it? I would first measure whether time is spent downloading dependencies, executing compilation, or pushing layers. I would configure Docker and package managers to use Artifactory remote repositories, then inspect the Docker file. Stable dependency installation should precede frequently changing source copy steps, and Docker ignore should reduce build context. Multi-stage builds can shrink the final image. I would avoid indiscriminate cache disabling, pin dependencies, and verify improvements with repeatable pipeline timing rather than assumptions. Discuss layer caching, Docker file ordering, Artifactory remote repositories, dependency proxies, Docker ignore, parallelism, cache invalidation, image size, build measurements, and reproducibility. Question 7. How would you troubleshoot a Kubernetes deployment that cannot pull an image from Artifactory? I would start with kubectl describe pod and inspect events for the exact pull error. Then I would verify the image path, immutable tag or digest, node DNS, network connectivity, and TLS trust. For private repositories, I would check that image pull secrets exist in the correct namespace and contain a valid token with read permission. I would reproduce the pull from the affected node when possible. Finally, I would confirm repository policy and architecture compatibility. Cover image naming, registry reachability, DNS, TLS certificates, image pull secrets, token scope, repository permissions, Kubernetes events, node runtime behavior, and distinguishing authentication from authorization failures. Question 8. What strategies would you use to provide high availability for Artifactory? For production, I would use an Artifactory high availability topology with multiple nodes behind a load balancer, redundant database services, and resilient storage. Health checks must remove unhealthy nodes without sending traffic to partially initialized instances. I would define RPO and RTO, automate backups, and regularly test restoration and failover. Network, identity, and external dependencies also need redundancy. Availability is not proven by architecture diagrams. Controlled failure testing validates the design. Mention redundancy, clustered nodes, shared or replicated storage, database availability, load balancing, health checks, DNS, backups, failover testing, licensing, and recovery objectives. Question 9. How would you manage repository growth and prevent Artifactory storage from becoming a bottleneck? I would establish retention by repository and artifact type, keeping release versions longer than development snapshots. Before deleting anything, I would identify references from builds, deployments, and compliance requirements. Automated cleanup should run in dry run mode first and produce an auditable report. I would monitor storage growth, I/O latency, and database performance, then scale capacity before exhaustion. Repository quotas and publishing standards prevent teams from treating Artifactory as an unbounded temporary file system. In your answer, include retention policies, cleanup jobs, unused artifact analysis, deduplication, repository quotas, large file monitoring, binary storage planning, and safe deletion procedures. Question 10. Explain how you would use infrastructure as code to manage a JFrog-based DevOps platform. I would manage repeatable configuration through Terraform or supported JFrog automation APIs. Repository definitions, permissions, projects, users, and selected integrations would live in reviewed modules, with environment-specific variables. State would be encrypted and access controlled, while tokens would come from a secret manager. Plans would run in pull requests, and applies would require approval. I would handle imports carefully for existing resources and schedule drift detection, because manual fixes otherwise create configuration divergence. Discuss Terraform or equivalent tooling, provider capabilities, repository configuration, permissions, variables, state security, review workflows, drift detection, imports, and avoiding secrets in source control. Question 11. What is build info in the JFrog ecosystem, and why is it valuable? Build info is structured metadata describing how an artifact was produced. I use it to capture the source revision, build number, dependencies, environment variables, modules, and produced artifacts. That information connects a release to its inputs and supports Xray scanning, promotion, auditing, and incident investigation. For example, if a vulnerable library is discovered, I can identify affected builds and deployments quickly. It turns an artifact repository into a traceability system, not merely file storage. Make sure to explain provenance, source revision, dependency and environment capture, build promotion, Xray integration, release traceability, reproducibility, and how pipelines publish metadata alongside artifacts. Question 12. How would you design a multi-team repository structure in Artifactory? I would begin with package types and lifecycle needs rather than create a repository for every team. Shared libraries can use well-governed local repositories, while virtual repositories provide stable consumer endpoints. Team or project boundaries should be represented through naming, permissions, and ownership. Snapshot, release, and container policies may require separate repositories. I would document conventions and keep the structure understandable. Excessive fragmentation increases administration, while broad permissions weaken isolation. Focus on package formats, naming standards, local versus virtual boundaries, project isolation, ownership, read and deploy permissions, lifecycle differences, and avoiding excessive repository fragmentation. Question 13. A production deployment introduced a bad package. How would you roll back safely? I would identify the exact deployed version from deployment metadata and select the last known good immutable artifact. Before reverting, I would check database and API compatibility, because application rollback may not reverse schema changes. I would use the platform's controlled rollout mechanism, monitor health and business metrics, and communicate status during the incident. After stabilization, I would quarantine the bad artifact, preserve evidence, and improve gates, tests, or progressive delivery to prevent recurrence. Cover immutable artifacts, deployment history, health checks, database compatibility, traffic shifting, rollback automation, incident communication, artifact quarantine, and post-incident prevention. Question 14. How would you authenticate C/CD systems to JFrog without creating a security risk? I would create separate non-human identities for build, promotion, and deployment, each with the minimum required repository permissions. Preferably, the C platform exchanges an approved workload identity for a short-lived token. Otherwise, tokens reside in a secret manager and rotate automatically. Secrets must never appear in logs, images, or source files. I would audit token usage and revoke unused credentials. Separating publish from promote limits the impact of a compromised build job. Discuss service identities, scoped access tokens, OIDC or secret manager integration, expiration, rotation, permissions, masking, auditability, and separating read, publish, promote, and administrative actions. Question 15. How would you diagnose intermittent latency when developers download artifacts from Artifactory? I would correlate client timings with Artifactory access logs, load balancer metrics, storage latency, database health, and network telemetry. I would separate local repository reads from remote cache misses, because external upstream delays can look like Artifactory failures. Testing from multiple regions and nodes helps isolate routing or capacity issues. I would inspect request concurrency and large file behavior, then validate a remedy with latency percentiles, error rates, and download throughput rather than average response time alone. Mention request metrics, client and server timing, network paths, load balancers, storage I/O, database health, remote cache misses, concurrency, regional distribution, and reproducible testing. Question 16. What observability would you build for a JFrog-centered delivery platform? I would monitor Artifactory availability, request latency percentiles, error rates, storage utilization, database health, replication status, and cache hit behavior. Pipeline dashboards should show queue time, build duration, failed stages, artifact publication, Xray violations, and promotion time. Deployment dashboards add rollout health and service level indicators. Logs need correlation identifiers and centralized retention. Alerts should reflect user impact or imminent risk, such as sustained failures or storage exhaustion, not every transient warning. Be sure to cover availability, latency, error rates, storage, queue depth, repository usage, pipeline duration, scan outcomes, deployment health, logs, tracing, dashboards, and actionable alert thresholds. Question 17. How would you migrate artifacts from another repository manager to JFrog Artifactory? I would inventory repositories, formats, sizes, consumers, permissions, retention requirements, and critical metadata before moving anything. I would map source repositories to an intentional Artifactory structure and test representative artifacts, checksums, permissions, and dependency resolution. A staged migration can copy historical content first, then synchronize changes during a short cutover window. Clients should switch through standardized URLs or configuration management. I would preserve the old system read-only until validation and rollback criteria are satisfied. Discuss inventory, metadata preservation, repository mapping, permissions, checksums, staged migration, validation, downtime planning, client cutover, rollback, and compliance retention. Question 18. How would you implement GitOps for Kubernetes applications whose images are stored in Artifactory? I would store Kubernetes manifests or Helm values in Git and reference images by immutable digest from Artifactory. A pull-based controller such as Argo CD reconciles approved changes, while image automation can propose updates through pull requests rather than directly modifying clusters. Promotion occurs after tests and Xray checks, with environment-specific repositories or metadata. Secrets remain in an external secret manager. Git history supplies auditability, and reconciliation corrects unauthorized drift. Cover declarative manifests, Git as source of truth, immutable digests, pull-based reconciliation, promotion repositories, image update automation, policy checks, secrets, and drift correction. Question 19. How would you enforce dependency management and prevent supply chain attacks in C/CD? I would route dependency resolution through approved Artifactory virtual repositories and block direct, uncontrolled internet access from builds. Lock files, pinned versions, checksums, and reproducible build environments reduce substitution risk. Xray watches would enforce vulnerability and license policies across artifacts and builds. I would generate provenance, review automated dependency updates, and isolate build agents. If a malicious package appears, I would quarantine it, identify consumers through build info, rotate affected credentials, and rebuild safely. Include dependency pinning, lock files, approved repositories, checksum verification, Xray watches, license controls, provenance, malicious package response, isolated builds, and dependency update automation. Question 20. Describe a DevOps improvement you would prioritize during your first months at JFrog. I would first map the delivery path from commit to production and interview developers, security engineers, and operations teams. After baselining lead time, failure rate, recovery time, and artifact-related incidents, I would target the largest bottleneck, such as slow builds or unclear promotion rules. I would deliver a small improvement, measure it, and expand only after proving value. At JFrog, I would favor automation that improves developer speed without weakening provenance, security, or reliability. In your answer, connect customer impact to measurable outcomes, baseline current performance, identify bottlenecks, collaborate across teams, deliver incrementally, and define success metrics with operational ownership. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.